My name is Mohammed Afzal. I'm engineering architect at Cisco System. I'm part of Cisco UCS Solution Engineering Group. Today I'm going to talk about the UCS integrated infrastructure and Cisco ACI with Red Hat OpenStack platform solution. White paper is already published in September of 2016. As you can see, the topology on your right hand side, which shows you the component involved, high-level physical topology. And in this demo, we are going to show you how ACI has to be configured for this solution to work. ACI requires some pre-OpenStack deployment configuration, and once it's all configured, then OpenStack can be deployed under cloud and the over cloud, and the plugin ACI plugin, and after that the plugin takes care of rest of the integration, automation, orchestration of the OpenStack related activities within APIC infrastructure. But in this demo, I'm only going to walk you through what are the areas, how the ACI has been configured for the OpenStack environment. Let's take a look at this cabling diagram real quick before I'll be referring to this back and forth. Especially this entire configuration requires a very close attention to this port channel configuration between the fabric interconnect and the leaf. We also have some other interfaces configuration. For example, this is the VPC that you are seeing is configured for out-of-band management switch. That actually gives us the ability to utilize ACI fabric for management and external connectivity from our jump host. As you can see that if our jump host is connected to the outer management switch, it can actually reach to the leaf through this connectivity, and also an interface for L3 network. That is also important. Here we just configured it a single interface for simplicity. Although two interfaces, both the leaf can be connected to existing L3 network to have a more redundant path, but this was just a lab environment. So for ease, we just configured one interface to give you an idea how to configure the interfaces for different kind of connection, VPC and L3. So here is the ACI APIC view of these connectivity. Let me quickly go to the place how I got to this place first. I think the session expired while I was clicking. So you go to the fabric access policies and you first create those VPC here, since they're already created. So there is one VPC for interface 118. As you can see that if we recall the cabling diagram, 118 is the one on both leaf 101 and leaf 102. One is connected. Both are connected to the fabric B. So 118, as you can see, both the switches 101 and 102 has been configured for VPC, and then there's another VPC is configured for 117, and this is the individual interface configuration. This is just for L3 port 137, which is, if you look at it, 137 is just connected to this port, so it's an individual port configuration. And this is the VPC that is actually connected to the top of rack switch. As you can see that 123 and 123 on both the switch 101 and 102, leaf 101 and 102, port 23 is configured in the VPC configuration and allowing VLAN management and the external. 10 is the management and 219 and this one is allowing different VLANs. The, you know, I'll show you more detail once I get there, because this screen looks different once you start adding the interface. Right now is only showing you a very brief information. For example, if I click on that, it's going to show you a lot more information in terms of how it has been configured. Like, you specify both the switch, then it automatically creates a switch profile, and then you click the plus sign to configure the interface, and now you can see, like, how everything has to be configured. So I selected the VPC, for example. If I'm just configuring 1-17 interface, just like, for example, this one, and link level policy should be default, so it doesn't matter. By default is all 10 gig. So here the port channel, of course, LSCP active, and the CDP policy, you can specify enable CDP, enable LLDP, depending on monitoring policy. If you have any, you can use, otherwise you can use default. For Fabric Interconnect, you specify the bare metal, and then it's going to create a domain for you. For example, if this is the FIB connectivity, so you specify a domain name, any name, and here you specify what VLAN you want to allow in that VPC connection. Here we allowed management, and then we allowed 20 is the PXE, then 30 for storage, public, and storage cluster, and then few other VLAN. If I look at it, 10, 20, 30, and 219 is the external. So once you start, right now is giving some error because I think this profile already exists. I'm just showing it to you how it was initially configured, and then repeating the same for 17. If it's not there, then you should be able to hit save, and you should be able to hit submit. Of course, the VPC domain should be created first. So I'm going to cancel all of this so that once it's all created, then it's going to create a lot of things on its own. Previous interfaces, previous version of ACI was different. You can create each and individual things. For example, you can create the physical domain, and then you can create the AEP, attachable entity profile. You can create switch policies, things like that. But this newly created interface actually has automated a lot of things. It creates on its own. For example, I was showing you FIA, so as soon as you provide that, it just creates the FIA physical domain for you, and it actually created a VLAN pool also, as I specified the VLAN for in the previous section. So you can see that 10, 20, 30, so it creates those pool for you, and also attach it with the domain. So the domain has this pool, so you can create all of this by clicking those section as well, by right clicking, and create a VLAN pool, and you can do that as well, the older way of creating those things. But now in the recent version, if you go into the interface policies, and you right click and you do that, it creates a lot of things for you. So the switch profile, it was already created. So if you go into other profiles, so you can see that switch profile is there. So like I said, that screen creates everything for you, even the AEP, attachable entity profile for FIA. It also added the VM, the physical domain that we have created. So for B, another one was created, like I said, for out-of-band management. If you remember that, there are out-of-band management VPC as well. So AEP was created, and even for the L3. So that was the L3. So any interface we have, we created all of them one by one, and it created those AEPs. And also the switch profile is common because it shows all the interfaces, and a few other things got created as a result of that interface. Some policies that we created it separately, all are outlined in the white paper. If you missed that link, let me bring it for you. The white paper link was in the very first slide, so you can go to this link and you can actually find out more information, how to create those policies. So we created the CD LLDP policy, enable LLDP. We created that, and also the port channel one, which is the LACP active, which actually we used from. So those has to be there before you actually start creating a VPC configuration. So, and as we expand few things, as you can see that this is the switch profile that was also got created. That's where we were getting that error, like it's already exists. So as you can see, that switch profile shows the leaf 101, 102, and that is actually being utilized and pre-created in one single screen. So a lot of it are orchestrated. So once VPC is configured properly, VPC is the most important thing that has to be configured properly. Once the VPC is configured, you can go to the fabric policies inventory, and then you click the pod 1, the leaf 1 interfaces, and VPC interfaces. It actually shows you the health. So you need to see that it should show 100% and should be up and successful. So it can also be looked at by logging into the leaf switch. So you can SSH to leaf switch by logging in, and you can type show VPC. So when you do that, right now, initially when you configured it, you actually don't see active VLANs. Those active VLANs starts to show up when you start creating the static path within the application profile. So I'll show you once we get there. So but the only thing is it's going to show you that success, the VPC is up and consistency is good, and the active VLAN starts to show up later on once we start configuring the infrastructure tenant. So this is the place where we can see the VPC. So this is one of our VPC for FIA or for FIB, and that's the other one for you can see allowing only VLAN 10 and 219, which is the external VLAN. So it's the VPC for top of rack or out of band management switch, and these are for fabric interconnect, which was actually allowing VLAN for a lot of other traffic. And as you can see that we configured these VLAN only from where these VLAN came in, 25341. So these are actually OpenStack related VLAN that was created by the plugin and associated to this VPC. So once you create a VLAN inside an OpenStack environment, a subnet, the in cap has been assigned from the range of the VLAN ID that we specify in the configuration. So if you look at it, so here is the range that has been specified As you can see that 250 to 749 is the range we specify during the installation of OpenStack under VLAN configuration. So the segmentation ID get assigned to the neutron network, and then the in cap is created here, and it's attached to the same VPC for has to be for the networking to work. So the plugin takes care of it. Those are the VLAN interfaces. Those are the VLAN that actually came in as a result of neutron networks being created. This is the infra VLAN 3967, from where this VLAN came in. So this VLAN starts to show up in the VPC as it's showing up here as well. You know, the 3967. If you see that, that is actually the in-band infrastructure VLAN, and that has to be added in the VPC as well for OpenStack Offlex to work, because if this VLAN is not in there, the compute host will not be discovered within the ACI infrastructure in-band network via LLDP, and the interface has been configured in each compute host. So if you log in, there are some configuration in each compute host that is also all outlined in very detail in the white paper, how it has to be configured. But how this VLAN starts to show up in that VPC. So if we go into the attachable entity profile of FIA and FIB, so interface policies, global policies, FIA, if you checkbox this, as soon as you checkbox this, and then if you do show VPC, that VLAN starts to show up in the port channel for both A and B. It is a very important step. If you don't do it, your compute host will not be discovered inside ACI in-band infrastructure. So now let's go back to the next step after all of this is done. So you go to the tenant section. We just created an OSP infrastructure tenant. This is just a foundation tenant that actually allows some of the traffic to pass through. For example, management and Pixie and other storage related traffic. Usually storage related traffic, Ceph related traffic, and in most cases Pixie. They are usually if you look at the topology diagram, they are usually switched locally. For example, if the blades are sending traffic on Pixie, they are usually switched locally within the fabric. But what if one of the fabric goes down? So then it starts to go up. So you need to have those VLAN should be allowed in those VPCs that are connecting fabric to the sleeves, and the traffic should traverse inside the ACI infra network, for example, the leaf and spine, so that it comes back. If the fabric B is down, comes here, leave and spine, and then comes back to complete the network. So ACI infra network is something, OSP infra is the tenant we created, and then we started creating those service application profile within it. So for each type of network we have here, we have actually created a bridge domain. For example, these are the infrastructure related VLANs, Pixie, for provisioning network for OpenStack, and we have management, which actually allowing out of band management to the host, and not only that, is also being used for OpenStack internal API network. So if we expand, and then storage cluster and public, which is for Ceph, carrying storage public traffic and also the storage cluster traffic. So you can see that this is each type of network we have, and the last IP has been used to create an SVI. and in each one of them, if you look at it, is the Pixie subnet also and the management. And one is for external also, which is for outside world, for internet access. So now the application profile, as soon as you start creating application profile, like I said before, these VLAN 10, 20, 30, and 40 don't show up in the VPC until you have the static binding for static paths. For example, management, once you create that application profile and then go to the static binding paths, and you add those paths and in cap. So once you specify that in cap, and then when you see it, so it's both the path, one for the switch 1 or 1 at the leaf 1, and then for the leaf 2, and this one is of course for port 23, which is actually the out of band management switch. So as we said earlier, VLAN 10 and 219 is also connected to the out of band. But if you look at the Pixie, you won't see the Pixie is not going into the out of band, so you only do the static path for just the VPC for the fabric interconnects. So same for the external. This one is going to the out of band switch also. So we have application profile for each type of traffic we have here. So once they are all done, then your VPC starts working and allowing those VLANs and traffic. So that's a very important configuration. It's a foundation tenant. We have to configure it. After that, we are able to deploy undercloud, because undercloud is also using ACI, and another important aspect of it is the common tenant. So common tenant, actually, this is the place where we configure L3 out, which is external routing network. So L3 out is again independent of OpenStack. You can configure it many ways. There are a bunch of documentation out there. You can configure it via using OSPF, EIGRP, or static routing, depending on what kind of setup you have. And again, it's independent. It has to be pre-configured and tested, making sure that L3 out is working, because once it's all confirmed that it's all configured and tested, although the very basic static routing type configuration has been included in the white paper, but more advanced routing configuration is available in the APIC documentation or ACI documentation, which can be utilized as well. So the L3 out is configured and tested. That's the network, the L3 out, you actually specify in one of the ini file for the OpenStack VM to utilize SNAT functionality, which is for those VM who do not have a floating IP and still wants to have an outside access, and also for the floating IP. So once you have this configured properly, then you will have those features will be working for you. So again, the configuration can be found in many ways, but it's just showing it's important to have this configuration. And OSP infra net tenant name is irrelevant. You can give any name, and the fabric interface configuration. So as you have the APIC up and running, you can have the ACI interfaces configuration for the rest of the infrastructure, for the fabric interconnect, the out-of-band management switch, L3 interface, and then you create an ACI infrastructure foundation tenant, and then you configure L3 out. Then you have this ACI environment ready. The other configuration are optional. For example, if you want to have out-of-band management connectivity, that you can do so that you can have SSH to all the devices, spines and leaf, just like I have. I just SSH to it. If you don't have it, you can always SSH as well from APIC to those leaves and spine, but I am doing SSH because I have configured out-of-band management connectivity as well inside APIC. If you look at this diagram again, this is out-of-band management switch. So my jump host is connected to this switch, and on VLAN 10 I can actually reach to leaf, and that's where this out-of-band management connectivity is allowing me to get into those switches. Otherwise, you can go into the APIC, and from APIC you can go into any switch you want to with an ACI infrastructure. There is a place for configuring. There is a place for configuring ACI out-of-band management connectivity. So let me find out VM networking. This is the place for where the hosts are discovered, and let's go to the system. So if you look at system, it shows you the controllers. In our environment, we only have one APIC controller in our lab environment, so it shows you the topology, how it has been configured. If you click General, it shows you the ACI infra VLAN that we actually, it's a default, we didn't change it, but once you are configuring the APIC, you can actually change it. And this is the out-of-band management IP that we have given to the APIC. APIC and the ACI, they're all upgraded after they are cabled rack and stack to 1.31G. The upgrade information is also available on the ACI documentation. Some troubleshooting if there is any faults in history. So these are controllers, and if we go into dashboard, there are a lot of health related information with respect to the controller. As you can see, there is one fully fit, and there are a lot of other information which you can see. There are a bunch of videos for tutorial within the APIC itself. This is the tenant. So you can see the troubleshooting information, admin tab, that is allowing you to configure different type of authentication within the ACI. That's the firmware upgrade section. So you can see the controller firmware. We have successfully upgraded it, and here you can actually create a catalog of the firmware. You can also create a firmware repository. L4 to L7 services is beyond the scope. We didn't do anything. No configuration for L4 to L7 services. That's all for now. These are other tenant that was created by the Offlex plugin, and as soon as you create a new project in OpenStack, they are actually created as a tenant in APIC, followed by the system ID that we actually specify in configuration of Offlex. And that's all for now. Thank you very much for watching this video.